Hi all. This is the 10th class of Manufacturing Process Module 1. In this section, I am going to discuss about casting defects. So this is the last class of Module 1 actually. After discussing casting defect, we can wind up the Module 1. Okay. See, casting defects are basically classified into three types. That is first one, surface defects. Second one, internal defect. And third one, visible defect. Surface defect means that is commonly occur in the surface of a casting. Internal defect means it is internal inside the casting. That is an internal defect, not surface inside the casting. And visible defect means the defect is visible by our naked eye. So these are three classification of casting defects. In surface defects, we have blow, scar, scrap, drop or crush, penetration, flash or fin, blister. So these are the classification of surface defects. Internal defect, there are three classification of internal defect: blowhole, pinhole, and inclusion. Then last one is the visible defect are wash or cut, hot tear, shrinkage, rat tail, bar buckle, swell, shift or mismatch, misrun, run out, and fusion. So we can discuss one by one. So first one is blow. See, blow is basically large cavities produced by gases which displace molten metal from the mold. Blow occurs convex casting surface. See, a blow is basically a large cavities that will be formed on the surface of convex casting surface due to gases which displace the material. So this is known as blow. Large cavities that will be produced in the convex shaped casting surface. The reason for blow is the gases which displace the molten material. Okay. Next one, scar. Scar is a shallow blow that generally occur in flat surface. If these cavities are found in a flat surface, top of flat surface, that is known as scar. The reason of scar is came as blow, the gases which displace the material. Third surface defect is the scrap. Scrap are defined as rough irregular projection on surface of casting containing embedded sand. That's the definition of scrap. Rough irregular projection on surface of casting containing embedded sand. See, this is surface of casting. If the surface of casting have rough irregular projection containing sand, that is known as scrap. See, the fourth one is drop. Drop or crush. See, drop or crush means this defect occur a portion of the mold breaking and dropping into the metal. A portion of mold cavity or mold core breaking and it will dropping into the mold metal, that is known as drop or crush. Next one is fifth defect is the metal penetration. See, metal penetration means you can visible metal penetration as a irregular portion over the surface of a casting. And the reason for metal penetration is if the liquid metal have high fluidity, it will penetrate into sand mold or sand core. And there will be, after solidification, there will be several projection over the surface of casting, that is known as metal penetration. The main reason for metal penetration is high fluidity of molten material that will penetrate into the space between sand particles, and after solidification it can be visible as a projection over the surface of the casting. Sixth surface defect is the flash of. See, flash on fin means there is some projections of material in the parting line of the casting due to the molten material, excess molten material that flow into the parting surface. See, suppose this is a casting, this is the flash. This is due to excess molten material that flow into parting surface. Then next one is seventh surface defect is blister. See, blister is a shallow blow like a scar with a thin layer of metal covering it. Blister means it is a shallow blow like a scar. But what is the difference between blister and scar is in the case of blister, a thin layer of metal covering the blow or scar. Thin layer of metal that will covering this scar, that is known as blister. So these are the surface defects, mainly surface defects. We have blow, scar, scrub, drop or crush, penetration, flash or fin, and blister. So next one is internal defects. There are three classification of internal defects: blowhole, pinhole, and inclusion. So first one is blowhole. See, blowholes, it is also known as gas holes or gas cavities, are well-rounded cavities having smooth surface. This is due to the gases carried by the hot metal. So the gases are entrapped inside the casting and that cannot be escaped, and that space will not be filled with the molten material. So the main reason for blowhole or a gas hole or gas cavities are gases that trap inside the molten material. And the blowholes can be controlled by controlling moisture content in the sand mixture, providing proper venting, not too hard ramming of the mold, and controlling binders. So these are the parameters that can be controlled to reduce the blowholes defects. By controlling moisture content, providing proper venting, not too hard ramming of the mold, and controlling the binders. Okay. And second internal defects is the pinhole porosity or gas porosity. See, the pinhole porosity is due to gases absorbed by the molten material. The defect porosity is due to the gases absorbed by the molten material. Actually, the metal absorbs oxygen, hydrogen, nitrogen, and oxygen and nitrogen form oxides, and that will be dissolved in the molten metal. See, the hydrogen that is responsible for the pinhole porosity. The molten metal that will pick up hydrogen from fuel, moisture in the air, mold, etc. As the metal solidifies, the solubility of hydrogen will be decreased. When the metal solidified, the solubility of the hydrogen will be continuously decreased. Then the hydrogen that comes out from the casting, forming a number of small holes distributed throughout the metal, that is known as pinhole porosity. So what's the meaning of pinhole porosity is the main reason for porosity's defect is due to the gases absorbed by the molten material. The reason for pinhole porosity is hydrogen. See, the molten material that will absorb hydrogen from the surrounding atmosphere, mold, etc. During the solidification time, the solubility of hydrogen will be decreasing. When the solubility of hydrogen will be decreased, the hydrogen coming out of the casting forming a number of small holes distributed throughout the surface, that is known as pinhole porosity. Okay. Then third internal defects is the inclusion. Inclusion means any foreign particles that will be present inside the casting is known as inclusion. So these are the three types of internal defects present in a casting. First one, gas hole. Second one, pinhole porosity. Third one, gas hole means blowhole, pinhole porosity. Third one, inclusion. See, next one is visible defect. There are a lot of visible defect you have to study. Okay. First one, wash or cut. See, wash or cut is a projection on the drag face of the casting. So this is the drag face of the casting. Wash or cut means there will be a projection on the track face of the casting along the surface, decreasing in height as it extends from one side to other side, known as washout cut. So washout cut, that's the projection on the drag face of the casting extend along the surface, decreasing height when it moves from one end to another end. That is known as washout cut. Second defect is the hot tear. Hot tear is ragged, irregular internal or external crack occurring immediately after the metal has been solidified. Hot tear is defined as the ragged, irregular internal or external crack immediately formed after the metal has been solidified. That is actually a solidification defect due to sudden change in cross section. Okay, the hot tear will be coming. You can see here. See, shrinkage cavities. Shrinkage cavities means due to shrinkage, volumetric shrinkage of casting during solidification, there is some cavities will be forming over the surface of the casting. That is known as shrinkage cavities. See, you can see that this is the cavity will be formed due to the shrinkage. Shrinkage means volumetric contraction that will be occurring during the solidification time of a casting. Due to shrinkage, there is some cavities that will be formed over the surface of the casting. That is known as shrinkage cavity. Next one is a swell. Swell is defined as the enlarging or bulging over the vertical face of the casting. Enlarging or bulging the vertical face of the casting. This is due to improper ramming or the ramming not properly reinforcing in the deep mold. Improper ramming is the main reason for the swelling. In the vertical face of the casting, there is a bulging or enlargement will be coming. That is known as swell. You can see here, this is a swelled portion casting. Next one is shift or mismatch. See, the main reason for shift or mismatch is the top and bottom portion. That means cop and drag portion of the sand casting mold are not properly aligned. If there is any problem in alignment pin and the cop and drag portions of the sand casting mold are not properly aligned, the defect mismatch will be coming. Shift or mismatch will be coming. Next one is misra. See, what's the main reason for misrun defect is the casting has solidified before completely filling the mold cavity. If the casting has solidified due to low temperature of molten material, there is a chance that the casting has been get solidified before the entire mold cavity has been get filled. That is known as misrun. Next one is cold shunt. See, cold shunt means if there is multiple gates are provided in a mold cavity and molten material flow into the mold cavity through multiple gates, these molten material will contact each other, but they're not fused together. That is known as cold shunt. Two portions of metals flow together, but there is no lack of fusion due to premature freezing, low temperature of molten material. That is known as cold shunt. So this is the gate and this is the next gate. Molten material flow through these gate and also these through gate. It will contact each other but not fuse together. That defect is known as cold shunt. Next one is runout. There is no figure for runout. See, runout means runout occurs when the molten material leaks out of the mold during pouring. During the time of pouring molten material into the mold cavity, the molten material leak out and there is a defect will be caused, that is known as runout. See, this defect caused by defective mold box, faulty clamping and weighting, and by casting too near the edge of the mold, edge of the box, etc. So the main thing in runout is during pouring time there is a leakage occur and the mold cavity will not be filled. That defect is known as runout. See, next one is fusion. See, if the sand particles have no refractory strength, the sand particle, sand grains or sand grains that will fuse with the solidifying casting, and the casting surface is not smooth, and that is known as fusion. See, the sand mold does not have enough refractoriness, or the metal is poured at very high temperature, or facing sand is poor quality. The sand may melt and fuse with the casting surface. This gives glossy appearance to casting. That defect is known as fusion. So the main reason for fusion defect is the sand have low refractoriness. If the molten metal is poured at very high temperature, or facing sand have pure quality. Next one is buckle. Buckle is V depression that occur on the surface of a flat casting. See, you can see that there will be V depression here, V depression here, and that V depression is known as buckle. Long, fairly shallow, broad V depression that occur in the surface of flat casting. That is known as buckle. Rattile. Rattile is long, shallow, angular depression in the surface of a flat casting. It is not shaped like a V. Other than V shape, if a depression is found in the flat surface of a casting, that is known as rattile. So these are the classification of defects in casting. This is a very important topic. There is a chance that question will be asked in this portion. Explain the different types of defects in casting, etc. So we have internal surface defect, internal defect, and visible defect. Okay. So we are moving to the last topic in the first module. This topic I am not taking class. I am giving as a self-study. See, the entire note is provided in the lecture note. Super alloy production method. How we are producing the super alloy production methods. So we have three methods of super alloy production, that is vacuum injection molding, electroslag melting, then vacuum arc melting. So these are three methods of super alloy production method. Vacuum injection melting. So the figure and all are given here. And electroslag melting. And last one, vacuum arc melting. So this is not a much important topic actually. There is no question will be asking regularly from this portion. So I am leaving this as a self-study portion. Okay. So these are the content in module 1. Okay. So module 1 completely dealing with the casting process. In next section, we can discuss the previous question paper based on module 1. Okay. Okay.